So let's start, students. Uh, Here you can see that it is water here, and it enters a pipe, meaning that it is an internal flow problem. To that, you have to write what is given in question. Given that T in is equal to 30 degrees centigrade, and the diameter is given as 25 mm, and the velocity is given as 0.06 meters per second. The pipe surface temperature, T wall, surface temperature means T wall, it is given as 50 degrees centigrade. Assuming both boundary layers to be developing simultaneously, meaning this is a fully developed flow. The meaning of this is fully developed. So determine the exit temperature. Determine T exit. What it is? T outlet he is asking. If the L is 1 meter, this is first problem. L is 4 meters. This is the second problem. And L is 10 meters. This is the third problem. See, in this, can you find out the bulk mean here? T bulk mean is equal to T in plus T out by 2. Here, T out is not given in question. He's asking you to find it out. So you cannot take the T bulk mean. So all properties are to be taken at 30 degrees centigrade itself. So all property values are to be taken at 30 degrees centigrade. So at 30 degrees centigrade, you will write various values here. So now that you are clear with the bulk mean temperature, what is the next step to do? Next step to check whether laminar or turbulent. So what is the way to check whether it is a laminar or turbulent? Find out the Reynolds number. You have to do VD by nu. V is given in question. It is given as 0.06. 0.06. D is given as what? D is given as 25 mm. So 25 into 25 into 10 to the power of minus 3. By nu is unknown, so you have to get it from the data book. So mu is equal to, so it is given for water. So go to page number 30 in your data book. In your data book, go to page number 30. You will find water values. Water and air, you remember page numbers in the data book. Water, it is 30. Let me rotate it. Yeah, here it is 30. You need 20 and 40 values are there here. So in between 30 is there. It's a kind of taking average. If you take average of these two, you will get the interpolated value for 30, because 30 is the average value of 20 and 40. So the remaining things also you can take the average, right? So what you need here is nu. This one, that is the average of these two you have to take. So tell me what is the new value. New from data book, it is 20, it is 1.006, 40, it is 0.657, and we need it for 30. You can follow the regular method, or you can follow the average method also in this special case.
Sir, is it 0.8315 into 10 power of minus 6?
Maybe.
Okay, okay.
I don't have the answer with me. Cross check with others. So tell me what is the x value here? New value 0.8. Somebody is saying
315.
0.315. Huh?
0.8315
8315.
8315 into
into
10
10.
to the power of minus 6. That is the new value 0.8315 into 10 to the power of minus 6. Write this here also 0.8315 into 10 to the power of minus 6 meters square per second. Get the value of RE now, Reynolds number value.
1803.9.
1803.9. See, this is all rough work again. I'm reminding you. Don't write this in the exam on the main page. Right, the RE value, you got it as less than 2300. So what that does imply? It implies the flow is laminar flow. Is it clear? It's a laminar flow. Now that you know it is a laminar flow, what is the next step to do? We have to find out the H value. Once you have the H value with you can use HA delta T to find out the T exit. So how to find out the H value? You have to go to the laminar formulas here. These are all laminar formulas. From the laminar formulas, this is a constant wall temperature case here. So since this is a constant wall temperature case here, you can make use of this Nu is equal to 3.66. Okay, so that's the formula here. So from data book, see, I'm not writing this from data book and all. You write it in your book, otherwise you will not understand. It is from page number 132. Okay, the Nu is equal to 3.66. So H into D value is given as 0. It is 25 mm. 25 into 10 to the power of minus 3 by K. K value, what it is? You have to get it from the data book. Let's go to the data book and get the K value. For 40 you have, for 60 you have, 30 you have to find out. The K value is at the end. These two values 0.5978, 0.6280. 40 minus 30 by 40 minus 20 is equal to 0.6280 minus x by 0.6280 minus 0.5978. X value, tell me.
0.6129.
0.6129. So the K value is 0.6129 watt per meter Kelvin. Here it is 0.6129. H value, you tell me.
89.7.
89.7 watt per meter square Kelvin is your H. Okay, you're done with your H. What is the next thing to do? You have to get the value of T out. T out you have to calculate. For that, MCP delta T. Q stored is equal to Q convection. You have to use Q stored is M Cp into T in minus T out is equal to what is the Q convection? It is H into A into the delta T. T of wall minus T in plus T out by 2. Is it okay? This is M dot. M dot is nothing but rho AV. So M dot is rho AV. Rho is the density of this one. So I have to get it from the data book again. So go to the data book, check for the density. It is 1009.55. So it is 997. 997.5 kg per meter cube. And the rho values. You write it here also. 997.5 kg per meter cube. You need CP also. CP value also you get it from the data book. Here it is CP 4178 and 4178. So it won't vary anyways. It is 4178 only per 30 also. Joule per kg Kelvin. So you have rho with you, CP with you, everything with you. So let me write this even more properly here. Rho A V into Cp into T in minus T out is equal to H into A value is pi dl. Let me write A itself. T wall minus T in plus T out by 2. Like this, if you write the rho value is 997.5. The A value is pi by 4 d square. And in this d value, what is the d value in this? 25 into 10 to the power of minus 3. Okay. Now let's move to the V, that is velocity. What is the velocity value given in question?
0.06.
0.06 meter per second. CP you have found out just now. It is 41. What is the value? Somebody tell me.
4178.
4178. T in. What is the value for T in?
30.
30 degrees centigrade. It is entering with 30. This is unknown. You have to calculate this. H you have found out. What is the H value?
89.7.
89.7 watt per meter square Kelvin. This is joule per kg Kelvin. Yeah, this is kg per meter cube. This is meters. Area. What is the area here? Area is pi dl. Okay. So the d value is given to you here. The d value is 25 into 10 to the power of minus 3 meters. And the L value What is the L value? In first question, the L value is 1 meter, isn't it? Second, let me know if I am wrong. There are
Yes.
three things he is given. L is equal to 1 in the first question, no?
Yes, sir.
So you keep changing this L, you will get the remaining things. What is the T wall now? T wall, it's given in question.
50.
What is
50,
that?
50 degree. 50 degree
50
centigrade.
is given in question. So substitute that here. 50 degrees centigrade. And you know T in again. So where shall I write this? What is the T in value? 30 degrees centigrade. So in this, everything is known to you except the T out. But the tricky thing here is T out is on both sides. So you have to carefully eliminate what you have on LHS and write RHS and then get the value of T out.
91.54.
91.54 degrees centigrade. When L is equal to 1 meter, you have done. The same thing you do it when L is equal to, what is that, 4? Yeah, 4 and 10. L is equal to 4 meter. What is T out? L is equal to 10 meter. What is T out? Tell me what is L at 4 meter T out value, L at 10 meter T out value.
73.83.
73.83.
84.
See, others also cross check these values. Okay, one person need not be right. I don't have answers with me. So 73.9,
8.
73.84. Yeah, third one. L is equal to 10, you put and solve. Please tell me what is L is equal to 10 T out value.
71.45.
71.4 degrees centigrade. As L is increasing, the temperature is decreasing. Let's make that is making sense, so we can take it for granted. So let's move to the other questions. The other questions are, see here I have given one more example question. I will leave it as an exercise for you. Do it. So this is an exercise or practice question, and that is in the laminar case. So do it for yourself. Thermal flow. This is turbulent one. See, in a given question, you don't know whether it is laminar or turbulent. Okay, I'm giving headings here so that you will be in position to solve questions from so and so this thing. Okay, so it's not like you will be knowing it in the advance. In the exam, you will not know. You have to find it out. Okay, so next model here will be to solve a non-circular one. So now we will solve this
Sir, one
non-circular.
previous answer, sir. Previous question answers.
In this question answers, these are the answers told by somebody. I'm not sure about them. You can cross check with others. That's what this is what I have with me now. As someone told you from your side, you have to cross check. Okay, so regarding the exercise problems also, you cross check among yourself. Okay, do it for yourself. This is the answer I got, and what is the answer that was obtained by the others in your group. That will be of useful great use to you, especially these three questions that I gave you. You do it now right after the class. That will be of great help to you. Right, let us move to the next question here. It is a non-circular type thing. Where is this? Yeah. See, so far what we have seen is only a circular problem. Sometimes you may get a question wherein the tube where the air is flowing need not be a what do you call internal flow case. It can be internal flow case of a non-circular type also. Okay, it need not be a circular type every time, especially the ducts that you have in air conditioning system. Sometimes they are made a rectangular. Okay, so that kind of question only you have here. So what to do this kind of thing with this kind of problems? Let us see here. Again, he is giving air also flows through the main duct. Flowing through the duct is an internal flow. You will understand that it is an internal flow problem. Once you know that, what is the next thing? The next thing is finding out the bulk mean temperature. It is T in plus T out by 2. But is bulk mean known to you? It's not known, as this is unknown. T out is not known to you. So 20 degrees centigrade is actually T in. So you have to use T in itself. So this is given. T in is 20 degrees centigrade. So at 20 degrees centigrade, all property values should be taken. So you will write it all the values at 20 degrees centigrade. Keep this at the right side corner of your book or paper. Right, Tn is given and it's a rectangular system. The velocity is given as 6 meters per second, and the duct is having 40 centimeter by 80 centimeter rectangle.
Asking you the Q, determine the heat loss per meter length. So he's saying that L value is also known. The L value is given as 1 meter, and is giving the temperature difference also. It is 1. The delta T is also given. It is 1 degree centigrade, 1 degree centigrade, or 1 Kelvin is giving you the delta T. Okay, that's what given in question, and he's asking you to find the Q value. So tell me, how do you solve this? Tell me, how do you solve for Q first?
HA delta.
Yes. Did you guys speak? What is the formula for finding Q? Q is equal to HA delta T every time. Okay. HA delta T in case of any given uh, convection problem, HA delta T you have to use. So H you have to find out in this particular question. So before we go to the H, you have to find out what is the Reynolds number value. Okay. So for finding the Reynolds number value, what is the formula? Re is equal to rho Vd by mu, or V into D by nu. See, in place of D here, we will have something called as L. We have something called as L, small l, let us put. Or let us look at the nomenclature that is given in the data book, and let's use that. Keep moving your pages. If you have non-circular cross sections, what to do is given here. Okay, here various non-circular cross sections are given, and for this one non-circular cross section, the formula is also given here. Non-circular sections, you can see this, and here where else it is given. This itself is enough for us because nu values are directly given to us here directly. So what is the ratio of the length to breadth? You have to get it. Based on that, you can choose here. Let us look at that. So let's not put this as L. Let us keep it aside for now. And here the 40 centimeter and 80 centimeter are given to you. So here, what he's doing in this data book, he is taking the smaller one by bigger one. So you also do the smaller one by bigger one. It is 40 centimeter by 80 centimeter. Data book page number. What is that page number? 136. So it is 1 by 2. 1 by 2 implies what is the Nu value in case of a constant void temperature? The value is this one. It is 3.391. So Nu is equal to 3.391. And H by K or H into something by K is equal to 3.391. Right. So what is this, the blank that I have left here? What should be this? Somebody tell me whether you will take this 40 or 80. Again, for this, the answer lies in your data book. Here, you see something called as DH, hydraulic diameter, you have to make use of. Okay, 4 into A by P. 4 into A by P is the formula for using the characteristic dimension, or here it is called as hydraulic diameter. So let us use the DH itself here. DH. 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 So the DH is equal to 4A by P is the formula here. What is the area of the rectangle here? It is 80 into 40. Both are in centimeters, so you multiply with 10 to the power of minus 4. What is the perimeter? 2 times A plus B, that is 80 plus 40 into 10 to the power of minus 2. So somebody tell me what is this DH value? DH value.
సార్ అక్కడ ఏరియా ఫ్లో అంటే 40 into 80 అని వేయాలా సార్?
Yes, please tell me what is DH value.
.53.
You're speaking, somebody is speaking, but I cannot hear.
0.54.
సార్ ఏరియా ఫ్లో అన్నారు కదా సార్.
Speaking, but I cannot hear. I'm
Hello?
sorry. Let me log.
Check. Somebody speak out.
సార్ అక్కడ ఏరియా ఫ్లో అన్నారు కదా సార్.
Yeah, tell me. A అంటే
ఏరియా ఫ్లో కదా సార్. ఏరియా ఫ్లో ఏరియా ఫ్లో అంటే మనం ఆ డక్ట్ మొత్తం ఇంటరాక్ట్ అవుతున్న ఏరియా కదా సార్ తీసుకోవాల్సింది.
Yeah, I'll answer that. See, your area means flow area you have to take. That is, flow area means what? If the tube is like this and it is flowing against this, so the flow area will be this. That is this much. This is what you call it as a flow area. Is it clear?
Okay, sir.
Okay.
Yes, sir.
Area with which fluid is interacting means this whole thing you have to take. This whole thing. Okay. So that's the point where I am. Yeah, DH value, somebody tell me. Please tell me the DH value.
0.53.
0.53. Yeah? Is it right? Meters. So you substitute the same DH value here also. H into 0.53. The K of air should be known to you. K of air, anyways, mu also required for air at 20 degrees centigrade. So move to the 20 degree for air. Air is page number 42. Move to page number 42. Where is this? Here it is. So at 20 degrees centigrade, you have to take the new value also. Let me write it. 15 point. 15.06 into 10 to the power of minus 6. The K value is 0.02593 watt meter Kelvin here, meter square per second here. All right. The K value is 0.02593. 2593 is equal to 3.391. What is the H value, you tell me? Yeah. Please tell me the H value.
0.164.
0.16. I cannot hear you. 164 or something you have said.
1659.
59. Okay. That is the H value. This much low it is there. Huh? The H
Sir,
value.
Reynolds number greater than 2300.
1.659 వస్తుంది.
It's 1.65.
There's 1 point. Huh?
1 point.
So it is 1.659. Okay. The Reynolds number story also, let us see. The Reynolds number. Let us keep this aside. What is this page number? I should have written this here. 136. VDH. V value is given in question as 6 meters per second. Is this 0.53 correct? Somebody confirm?
Yes, sir.
Fine, then 0.56, 15.06 into 10 to the power of minus 6. RE value, tell me. RE value. Please tell me what is
Two
RE
one
value.
one double five
211.
155.37.
Sir, kinematic viscosity is 16 into 10 power minus.
I have not taken it properly. At 20 degrees for air, it is 30 degrees. A question, 20 degrees.
30 degrees.
20
20
degrees.
సార్
20. Oh, sorry.
సార్ మీరు థర్మల్ కండక్టివిటీ కూడా 0.02593 సార్
అదేగా
0.
తీసుకుంది.
తీసుకున్నారు సార్ కింద సార్ కింద క్యాలిక్యులేట్ చేస్తుంటే 0.2
Here I should correct it.
అందుకే 1 పాయింట్ వస్తుంది సార్ 0.1659 సార్.
Yeah, 0.02593. The H value should be corrected now to 0.16. 0.16. The RE value has to be corrected. It is 16.08. What is that? Tell me. 16. It is simply 16. No, at 20 degrees centigrade only, no? At 20 degrees
Correct,
centigrade, 15.06 is correct.
Correct only.
15.06 is correct. 20 degrees centigrade is given in question. So 15.06 is correct. Whatever written at first time is right. So RE value you tell me now.
211, 155,
155.38.
0.38.
This much you got it.
Yes, sir.
Sir, it is turbulent, no, sir. We have taken for laminar. No?
Yeah. RE is greater than 2300. Okay. This whole process is for laminar. This whole thing is, if it's laminar only, you have to take. Otherwise, you should not take. If it's laminar. Why? Because in the data book he has given these formulas should be used only under the laminar thing. Okay, laminar thing is given in the data book. So if the laminar is not given, you got the turbulent. What to do now? So again, that Boelter equation you have to use. Okay, that is your rescue always.
Sir, what is
0.02.
the formula, sir, in this case?
The same thing. Only at what dimension you are calculating varies. The dimension is same. It is 4a by p. That is the flow area by wetted perimeter. That is the hydraulic diameter you have to use. That is here. This one. Is it okay?
I mean, in data book, there is mu L by nu. Sorry, sir.
Where?
In 120, sir. Page number.
This one, huh? Which page?
120, sir.
Page number 120. Why did you go there? That is an external flow thing.
Oh, no, sir. Dimensionless constants.
Page number 120. Correct. Tell me. What is that you are telling?
Reynolds number.
Reynolds number. Question me. What is your question? Tell me.
There is another formula like mu L by nu. Sorry,
Reynolds number has so many formulas. Which formula you have to use is your question basically. Okay. So Reynolds number is equal to. Let me answer this question. This is actually a very good question. I must have covered this. Give me a minute, I'll cover it. See, the Reynolds number is equal to Vd by nu you will use in case of an internal flow. In case of internal flow, you will use D is the characteristic dimension here. Whatever the characteristic dimension that is there here, that is varying for the kind of flow. That is, if it is external flow, no. If it is external flow, you have to use L. Okay. If it is internal flow special case, if it is internal flow special case of non-circular, what you have to do is, for this, you have to use TH, hydraulic diameter, which is actually 4A by P. Is it clear now? So you will have various D values. This is called as characteristic dimension. This characteristic dimension will vary from case to case. So based on the case, we have to choose. Till now, we have done this one. That's why we have used a D till now. Just now, in the previous problem, we have used this one. And in the future problems, we will do this. This is not there for mid-exam as of now. We have only these two for the mid-exam. Is it clear?
Yes, sir.
Yeah. Where we are lost somewhere, it seems. Yeah, we are here finding out the H value in case of a turbulent flow. So RE value, you have it with you. You have already calculated it. Prandtl value is required for you. So go to the data book and get the value of Prandtl. The Prandtl value on the data book. It is in page number 42. And the Prandtl value is 0.703. 0.703. So done with the right hand side. Moving on to the left hand side, you will also have K requirement. So I will also take the K. The K value is, K is already taken, right? 0.02593. So I need not take it again here. So let's substitute the things here. Nu is nothing but H into dH by K, hydraulic diameter by K. So H into the hydraulic diameter is 0.53 by the K value is 0.025. What is this? 93, 0.2593 is equal to 0.023 into the RE value is 2113155.38 whole to the power of 0.8, and Prandtl is 0. What is that? Prandtl is 0.708. 708 or 3? 703. 703 whole to the power of 0.4. Repeating guess, so 0.4 you will use. So only unknown is H value is to be calculated. Tell me what is the H value fast. Let's quickly finish
17.7.
17.7 watt per meter square Kelvin is your H value. And what you need here is actually Q. Q is equal to H into A into the delta T. That's what is to be calculated here. And what about the area here? This is a key issue. Area with which the fluid is interacting. Here, it's a tube, but this particular tube is having a rectangular cross section. The rectangular cross section is there. What you do in case of circle, you will do pi d into L. pi d into L in case of a circle. That is perimeter into L you will do. Isn't it? Same case when it comes to rectangle, no. The perimeter is 2 into A plus B. If this is A, this is B. 2 into A plus B you will use, and into L you will use. That is again perimeter into rectangle only. Sorry, perimeter into length only you are using. Okay. So this is what the area formula is. So the area is equal to 2 into 80 plus 40 into 10 to the power of minus 2 to the L value is given as 1 in the question. And H value, we have found it out as 17.7. The delta T value is also given in question. It is given as 1 degree centigrade per Kelvin. You can substitute for all these values and get the value of Q. Tell me what is Q value. Fast.
$84.96.
84. Are you sure?
42.48.
42.48 is the right answer. You cannot tell the doubled answer. If you tell doubled answer, it's somewhere mistake a 2 or by 2 you have missed in the question. Right.